Today we build the first working real-time chat slice. Two authenticated SignalR clients connect to the same ASP.NET Core hub. One sends only the text, "Hello" from SignalR. Both clients receive one matching message with trimmed text, a new message identifier, a neutral member label, and a server timestamp. Blank text is rejected with a safe error, and an anonymous connection cannot negotiate with the hub. This is deliberately a hub-only checkpoint. There is no Blazor chat interface yet, and messages are not stored. The complete release suite finishes with 29 passing tests. The smallest useful SignalR mental model has 3 verbs: connect, invoke, and broadcast. A client opens a live connection to a hub endpoint. It invokes a public hub method, much like calling a remote method by name. The hub checks the input and broadcasts a named event to one or more connected clients. Unlike a normal HTTP response, the event can arrive later and can reach clients that did not make the call. The hub class represents connection behavior, not stored chat history. Keeping transport, trust, and persistence separate makes this first real-time slice easier to reason about. The application registers SignalR and maps chat hub at /hub/chat. A small receive limit reduces the amount of data one invocation can push into the server, while one parallel invocation per client keeps this teaching path predictable. The hub itself has the authorize attribute, so authentication covers connection negotiation and every public method without relying on each method author to remember a check. Existing ASP.NET Core identity issues the access token used by the test clients. Authentication proves that a known account connected. It does not make the message text trustworthy, so validation still belongs inside the hub. Send message accepts one string because text is the only value the client may choose in this slice. It does not accept a chat message object. If the caller could submit the identifier, send a label, or send time, it could create collisions, impersonate a trusted label, or rearrange the apparent conversation. A narrow method signature makes the trust boundary visible before we write any validation. The authenticated connection is necessary for access, but this episode intentionally uses the generic server-authored label member rather than exposing an email address or pretending that profile display names already exist. The hub normalizes text before measuring it. Null becomes an empty string, surrounding white space is removed, and the accepted length is 1 to 240 characters. Blank or oversized input produces a hub exception with a short, authored message. The client can show that expected validation result without receiving stack traces, type names, or internal exception detail. The transport level receive limit is not a substitute for this feature rule. One limits the incoming frame, while the other defines a valid chat message. Both are useful, but they answer different questions and should be tested at their own boundaries. After validation, the server creates the trusted envelope. It generates a message identifier, assigns the neutral member label, records current UTC time through time provider, and keeps the normalized text. The hub then sends a message received event to clients.all. All means every connection attached to this hub, including the connection that invoked send message, so the sender and observer receive the same authored representation. That shared representation prevents each client from inventing its own identifier or clock value. There is still no database call here. A successful broadcast proves delivery to current connections, not durable storage or later replay. The first security proof calls the SignalR negotiate endpoint without credentials. Because the hub requires authorization, the server returns for O1 unauthorized before a connection is established and before send message can run. This test matters because a protected page does not automatically protect a hub root, and hiding a connection button is never an access control boundary. Authentication answers who may connect. Message validation answers what an allowed connection may send. Later episodes can add room or tenant policies, but this checkpoint first proves the broad anonymous boundary through the real application host. The integration test creates 2 authenticated accounts and 2 real hub connection clients against the in-memory test server. Each connection subscribes to message received before it starts, which avoids missing a fast event. The sender invokes send message with surrounding white space. Both task completions receive a chat message, and the test asserts complete value equality. It also checks a non-empty identifier, the member label, trimmed text, and a plausible server timestamp. A separate connection proves invalid text becomes the safe hub error. Together those three tests take the full release suite from 26 to 29 passing tests. The tempting shortcut is to let the client send a complete chat message and broadcast it unchanged. Even an authenticated member can then forge the member label, reuse an identifier, submit a false timestamp, or send text that bypasses the intended rule. Accept only the value the person controls and author trusted metadata on the server. Two other claims would also be unsafe. A broadcast does not mean the message survives a restart, and a working hub does not mean a usable Blazor chat page exists. This slice proves authenticated real-time transport. It deliberately does not promise durable history, delivery to disconnected clients, or user interface behavior. We registered and mapped an authorized SignalR hub, accepted only message text, normalized and validated it, created the message identifier, member label, and UTC timestamp on the server, and broadcast one event to all current connections. Integration tests prove anonymous rejection, safe invalid text handling, and identical delivery to two authenticated clients. The checkpoint is runnable and complete for its stated outcome, while remaining honest about what it lacks. There is no chat interface and no stored history. In Episode 8, we will persist chat messages without trusting client metadata and prove that reconnecting clients can read authorized history.